Hi everyone, here's my last thing for rewriting polynomials. I kind of ended up having quite a few pieces, but hopefully none of the pieces are giving you much trouble. This last one may be new for you. It is a really important trick. We'll use it later this quarter and we'll use it at other times as well. And the trick is completing the square. So this really boils back to the perfect square trinomials that we mentioned when we were factoring. So remember that perfect square trinomials factor into a perfect square like this. And it doesn't have to be x plus a, there's other forms, but that's what I want to focus on for this section. So this means that we're really taking x plus a times x plus a, which when we FOIL is going to give us an x squared. Our outside inside is going to be ax plus ax. So we're going to have two ax's, and then our last is going to be a squared. Okay, so here is the question I have for you. We want to be able to go backwards. We want to be able to figure out how to create an x squared plus 2ax plus a squared type polynomial so that it will factor like this. So I'm going to give you one, and I want you to, if you need to, pause and try and guess the answers to these before I do. This is a really good learning activity. So x squared, let's say we started with x squared plus 6x, and my question is, what do I have to tack on, or basically, can you find the value of a, comparing back up to this? So what do I have to tack on to make a perfect square? We're trying to build perfect square trinomials. Okay, so pause if needed. The idea would be that we're saying that 6 is our 2a, which means that a has to be 3, which means if I want a perfect square trinomial, I have to tack on a squared, which is 9. Notice that when you go to factor this, it does in fact factor into x plus 3 times x plus 3, which is x plus 3 squared. Okay. So I'm going to try another one and then we'll work on generalizing. What if you had an x squared minus 5x and you were trying to figure out, it's always going to be positive since it's a square, what do I add on to make a perfect square trinomial out of that? So again, we're saying in this case that negative 5 is our 2a, which means a is negative 5 halves, which means a squared is 25 over 4. And when you go to factor that, it might look tricky, but what you're going to get is you've deliberately made this so that the two will be the same. It's going to be, I'm spacing out here. It's going to be our negative 5. It's going to be half of this number. Sorry, I'm spacing. So it's going to be negative 5 halves. It's basically going to be our a, right? That's what this says right here. So we find that a. We have to tack a squared onto our trinomial. And then when we factor, we get x minus a, x plus a, whichever it is, times x minus a. So this is x minus 5 halves squared. Okay, so now I want you to try and generalize. This is really what algebra is all about, is generalizing. What if I say, in general, if you have a leading coefficient of 1, so 1x squared plus bx, what would you tack on to make it a perfect square? So now I'm saying that b is equal to 2a, so I need to take b over 2 to get a, and I need to square it, which will be b squared over 4, right here. In fact, I'm not even going to write it that way. You can memorize that, but if you've seen it before, you've probably seen it not multiplied out. B over 2 squared, that's like the magic number. If you're going to complete the square, you take the number in front of x, that's called b, you cut it in half, and you square it. And then when it factors, you don't have to memorize this part unless you're really struggling with getting the factors. It's going to be x plus b over 2 times itself, which is x plus b over 2 squared. So to complete the square, let's just make sure I say it really clearly. On x squared plus bx, you would need to add b over 2 squared. Okay, so I need to go one step further with this before I move on. What we're really going to be doing is, actually I think that's okay, we'll jump right into examples. So if you want to complete the square on an x squared plus bx, you need to add b over 2 squared. Okay, so what we're going to be doing with this is we're starting with something that's already a trinomial. And it's not a perfect square trinomial unless I messed up in writing these, but I definitely don't think that first one is. So when you complete the square here, you will have a leftover constant. It won't all be in the parentheses. That is completely acceptable. The rewriting here, dressing up polynomials, right? Dressing up quadratics. What we're doing is we're dressing up an ax squared plus bx plus c type quadratic as an expression that only has one variable. So one of the ways you can dress up in quadratics can write any quadratic at all with a single variable in it. It won't show up twice, and that can be really handy when we're solving and when we're graphing. Okay, so here, x squared minus 10x plus 4 is definitely not a perfect square, and I don't think it factors, period. So what we're going to do to complete the square is we're going to kind of mentally segregate those two terms, and then we'll leave that 4 out there. So what I was doing in the last couple of examples was just throwing something in there to make it a perfect square. What I want to do right now is dress up what I've got. So I can't change its value. That's not allowed. I'm trying to maintain the same value, but dress it up in a way that gives it only one variable. So I want to do the same thing I did before. I want to take my negative 10 and I want to cut it in half, and then I want to square that. So I'm going to get negative 5 squared, which is 25. And to build a perfect square, I need to add that on. But I'm trying not to change the value of this expression, so I'm going to use, I think, our other famous algebra trick, the one that we haven't run into yet. I think this is the first time. One of our major algebra tricks is multiplying by 1. That's how we do most of our dressing things up, changing appearance. The other one is adding 0. You can add 0 anytime you want and it doesn't change anything. But if you're smart about it, you can do it in a way that changes the appearance, right? Doesn't change the value, but changes the appearance. So if I'm going to add 25, I'm also going to subtract 25 so that I still have the exact same value, but now I have a perfect square in the mix. So the x squared minus 10x plus 25 will factor into an x minus 5 squared. If you don't believe it, if it feels like magic, FOIL it out. X minus 5 times x minus 5. And then because these aren't actually perfect squares and we're not just throwing stuff in the mix, we're trying to keep the same value, you generally will have some sort of leftover constant, the minus 21, and that's completely okay. I still managed to change the appearance of my trinomial so that there's only a single x showing up. Okay, so let's do it again. This is a great time to try and pause and work through. The numbers are a little messier in the next one, but see if you can do it. If you get stuck, come back. I would do that all the way down. It's a really good way to help you learn the material, help you remember. Okay, so x squared plus 5x minus 3. So kind of the same idea. I'm going to mentally segregate off the x squared plus 5x. Not just mentally, I guess, since I'm writing it. I'm going to, on paper, segregate, on my tablet, segregate the x squared plus 5x. I need to add on 5 over 2 squared, which is 25 over 4. Ooh, I made messier numbers, but they are numbers we saw up above. If this is going to have the same value, I also have to subtract 25 over 4. Let me see on the last one. Okay, good. That was good. So this time when we factor, we're going to, this is a little trickier, but remember, whatever this value is, this is what you factor with. So you want half of your middle number, x plus 5 halves times x plus 5 halves. That's how it's going to factor. And then I think if I'm going to do this subtraction, I'm going to rewrite this as 12 over 4, right? That's multiplying by 1, 3 over 1. We can multiply by 4 over 4. 12 fourths, negative 12 fourths minus 25 fourths is negative 37 fourths. And there is my square completed. So again, what I end up with is not a perfect square, but it contains a perfect square. And the really important thing here is that getting down to a single x allows you to do some nice things that you would not have been able to do in that standard form we started out in. Okay, same thing. Pause and try this one if you're feeling confident. Things get a little weird when you have a number out in front. We've only talked about completing the square when you have a 1 out in front, but we can make that happen. So we mentally split off the x squared, negative 2x squared minus 8x. And then what we'll have to do is factor out whatever's sitting in front of x squared. So we're going to factor out a negative 2. That means we're dividing by negative 2. So we're going to be left with x squared plus 4x. And then we're going to leave our blank spot, and we still have a plus 1 tagging along. So to complete the square, we're going to divide 4 by 2, which gives us 2. We're going to square it, which gives us 4. If we're adding something in, we need to also subtract it out. But we have to be extra careful here because we didn't actually add in only a 4. I'm going to switch my colors. What we really added in, if you multiply this out, we have a negative 2x squared minus 8x minus 8. What we really added in was a negative 8. So what we need to do over here is add in a positive 8 to balance that back out, right? So that we really haven't changed it. We really just still have negative 2x squared minus 8x plus 1. So when there's a number out in front, you have to consider that distribution when you're balancing out, when you're making sure that you're really just adding 0. Okay, so when I go to factor this, the x squared plus 4x plus 4 factors into an x plus 2 squared. I don't know if you've noticed, but this sign in the middle should always mirror the sign of your inside-outside. That's the only way to make those things match up correctly. And then this is a plus 9. Okay, I'm going to stick with my purple for this last one. One more, again, this is a great one. Pause, try and work through it. It does have some fractions in the mix, but you've pretty much seen everything there is to this process, and then you can come back and check yourself. Okay, so once again, we're going to segregate our 2x squared and our x. We don't have a good way to complete the square unless we have that leading coefficient be 1, so we're going to divide out 2. And when we do that, we're going to end up with negative x over 2, negative x over 2. And remember, one of our rewrite things is you can always rewrite division as multiplying by the reciprocal, right? Even when it's integers. Even if you're dividing by an integer value, you can rewrite that as multiplying by its reciprocal fraction value. Oh, hold on. I'm going to leave my space. We need to add something. And then to balance it out, we need to subtract something, although every once in a while we end up subtracting a negative, and then it'll be plus. Okay, so here I need to take negative 1/2 and cut it in half and then square it. Again, remember that dividing is the same as multiplying by the reciprocal. So we're taking negative 1/2 multiplying by 1/2 and squaring. So it's negative 1/4 squared, which is 1/16. So we need to add a 1/16. And then when we go to balance that out, remember that really what you've got is a 2x squared minus x plus 1/8. You don't have to write that all out every time. But when we distribute, we really see that it's not a 1/16 but a 1/8 we added in. So we want to also subtract off a 1/8. Ooh, I was nice. I gave you common denominators. I may not have been that nice on your homework. It's randomized, so some might be nice and some might not be. So when we factor our perfect square, we're going to get an x minus 1/4 squared. And I think especially here, I'm going to show you the check. I really recommend checking if you're feeling like this just seems like magic and you're memorizing steps instead of understanding steps. What we get is the first is our x squared, fantastic. The outside two are identical, negative 1/4 x minus 1/4 x is negative 2/4 x, otherwise known as negative 1/2 x, right? So that's where the whole splitting that middle number, splitting 1/2 in half comes from. We want the two equal things that add up to negative 1/2, and those two equal things are negative 1/4. And then when you multiply the last two together, you get negative 1/4 times negative 1/4, which apparently I can't write what I'm talking, is 1/16. So this looks good. It does match up, and that's how complete the square works. It takes half of that middle number so that you're finding the two identical numbers that add up to that middle term, and that forces your last thing to be the product of those two, the square of that number. And then negative 1/8 minus 1/8 is negative 2/8, otherwise known as, right, negative 2/8, otherwise known as negative 1/4 when you cancel out that 2. Okay, so that's complete the square, and that should do it for rewriting polynomials. Thanks for watching.